And with that, I want to turn it over to our presenters for today. Our session is titled Supercharge Your HPC and AI Workloads with Slurm. And we're going to kick it off with Nick Ihli, the Director of Sales Engineering from SchedMD. Nick, take it away.
Great, thank you, Jay. Yeah, I'm excited to be here today and share with you a little bit more about Slurm and do that with our Google Cloud Platform partners. So we've done a lot of good work with them here at SchedMD and with Slurm. So most of you, I would bet, know what Slurm is. But in case you don't, just to make sure we're all on the same page here, Slurm is a workload manager. That's three main roles: is to allocate your resources, provide a framework to start and execute your workload, monitor that workload, and monitor the health of the workload as well as the compute resources, and ultimately arbitrates contention between all of the different workloads that are out on your environments, and applying its policies and business rules to make sure that the right people get access to the resources when they need. It's fully open source, fully fault tolerant, highly scalable, and we'll get into a little bit more as we go today about some of the capabilities that Slurm has and some of its unique features that are really driving a driving force in the industry today, especially in the AI workloads that we're seeing quite heavily in Slurm environments. Now, not as many people, though, are as familiar with SchedMD. And so I do want to cover a little bit of where I come from at SchedMD. So we are the maintainers and supporters of Slurm. So we're the only organization that is currently providing level 3 support for Slurm. We are the main code contributors and maintainers of the Slurm code. Along with that, we provide services on top of Slurm. Some of these services are just mainly support. That is one of our major offerings, is providing fantastic support to our customer base. One where we can help you eliminate any security vulnerabilities. You get those any security updates on average 4 months faster than non-supported users. We maintain all the patches for Slurm as part of support, and you're able to communicate directly with a Slurm engineer with regards to any issues or questions or how-do-Is with regards to Slurm. The person that you're talking to for Slurm support is the person that's going to be fixing your issue. We don't have multiple levels of escalations that it has to go through. You are talking with the Slurm engineer that's going to be fixing the code for you. Secondly, we provide as part of a Slurm support contract, we provide consultation. This is a massive value to our customers, where we can review your Slurm setup and configuration, provide you the best practices and optimizations that you might need to accomplish the specific use cases that you have with Slurm. You can have in-depth technical chats where we get on a session like this and work with you to overcome whatever challenges that you might have, or unique circumstances, unique use cases. Maybe you've been a Slurm customer for a long time, and then you got a new workload that's coming online, or a new type of user, and you need to understand and better configure in your Slurm configuration of how to bring that new workload or new user type into your environment. And so we can provide you with that. Also, we provide a lot of migration assistance as you're migrating from other schedulers to Slurm, and helping you take what you had been doing with that other scheduler and figure out the best way to do that within Slurm, and do that as quick as possible. And a lot of times we do those as part of a proof of concept 3-month engagement. We'll talk a little bit more about those as we go. Finally, the other major offering that we provide is a 3-day on-site training. This tends to be one of the greatest values that we can provide to customers, to give you an in-depth and comprehensive technical training on how to use Slurm from an administrative perspective as well as from a user perspective. It's one part lecture, one part demo, one part lab workshop hands-on, where you have a mini environment created for you, and then you can go and try out the different aspects of Slurm based on the different training case studies that we're going through. Where the goal is, by the end of that, you have a very good understanding of the ins and outs of Slurm and how to start managing that for your user base that you have. We do also provide, as part of our offerings, sponsored development of new features and capabilities. And we'll talk about some of those new features that are coming out in the next release here as we go. So let's dive into Slurm. We always like to say with Slurm, we can do more with it. There's a lot of capability in Slurm that it is providing in the industry with the different trends that are out there. We'll talk about a few of these items here today, specifically cloud computing, integration with Google's Cluster Toolkit, its policy engine. It's able to take all those different complex business cases that you have and make sure that you're hitting those use cases and getting the right workload through the system at the right time. One great thing about Slurm is it's actively developed. We are on a 6-month release cycle and are putting new features and new capabilities into Slurm every 6 months that are in line with all the different workloads that are adopting Slurm over the years. So one aspect of Slurm that is important to understand is that it's highly scalable and highly throughput. Right now, Slurm is on 60% of the top 500 systems. It scales to thousands of nodes and also tens of thousands of GPUs. Slurm currently resides on the largest AI shops in the world, and the AI data centers in the world, with tens of thousands of GPUs along with thousands and thousands of nodes as part of that. And it's able to handle that without sacrificing the speed of configuration, of startup, of job dispatch. We also scale to millions of jobs per day. And it's an aspect of workloads like in the EDA space or financial space where you're doing millions and millions and millions of jobs a day. And Slurm is able to maintain that constant throughput of millions of jobs a day. The other major aspect of Slurm that's really important to understand is with Slurm, you're able to match those complex business rules that you have all these competing needs from different organizations. And Slurm has a number of features to handle these different business rules. This is one aspect of Slurm that I think I find people that maybe tried Slurm a decade ago, where there wasn't as many of these features and capabilities, but in the last 10, 12, 13, 15 years, Slurm has added quite a bit of capability here. And so it's important to understand Slurm's got all those capabilities to do multi-factor priorities, to determine priority based on who is most important, which projects are most important, fair share to balance the usage of the environment, quality of service that provide a number of different usage limits and ways to curtail usage and give better access to different resources. As a full accounting system where you can go and track all the usage of workload over a historical period of time, and also create a hierarchy amongst your accounts and users and providing different levels of access for those users. The common idea of a queue in Slurm is called a partition in Slurm, and within that you have ways to group your different workloads together, group the nodes together in different ways, and put different policies on those. Supports preemption as well as license management to handle those different software licenses that you have and do that in a dynamic way. Along then with SchedMD services, we work with you to take all these different capabilities and features of Slurm and configure them in a way that's going to be as most optimized for what you're trying to accomplish. So you can have that near 100% utilization of your resources, as well as balancing that with the needs for these different business rules. As the industry has shifted a lot to AI workloads, so Slurm has been a stalwart piece in that puzzle of AI workloads. It's uniquely designed to work with AI workloads because it has a very tight integration with GPUs. We work very, very closely with our GPU partners, NVIDIA and AMD as well, where we are trying to make sure that all the new chips that are coming out, that Slurm works with those and integrates with those to provide you the best results with your workload. We treat GPUs like a first-class citizen. It's treated just like a CPU, where GPUs can be named. You can bind tasks to GPUs. We support managed instance groups, auto-detect the GPUs. We're able to constrain your job to the allocated GPU that you are requesting, so the job can't escape that GPU and kind of mess up the environment where you're using more than you've requested and step on toes of other jobs. You're able to know which GPU is assigned to your job so that you can get access to that specific GPU and more optimally run your workload. We're constantly working with the likes of like NVIDIA to, again, make sure that any new chips they're putting out, that Slurm is going to work with those optimally. So let's talk a little bit about what's coming new in Slurm. We are on a 6-month release cycle, and so we're putting out new versions every 6 months. But we do have a new project that's related to Slurm called Slinky. So Slinky is basically Slurm and Kubernetes integrated together to create this new toolkit of components. It's really a set of projects that we have to integrate with Kubernetes. We've seen within the industry, especially with the AI workloads, you have a lot of sites that are looking at Kubernetes that come from a Kubernetes background, but you also have your HPC, traditional HPC workloads. So the idea is to bring these two together so that you can get a couple of benefits out of this. One, utilize a single environment for your Kubernetes and your Slurm workload. Let Kubernetes do what it does well for maybe your longer running workloads, and let Slurm do what it does well with regards to scheduling and multi-node and multi-GPU and very large workloads, where with Kubernetes, about 1,000 nodes or so, you can run into some problems. Slurm can run workloads way beyond that. And so the idea is that we have a couple components here. One is called the Slurm operator. This is managing Slurm as basically a Kubernetes application, whereas Kubernetes is auto-scaling Slurm nodes, adding more nodes to a resource pool, and then subtracting those nodes when they're no longer needed. So you have your workload come into Slurm, and then those nodes grow and shrink. Somewhat similar to what we're going to be talking about today with regards to cloud computing. Also, as part of this project, we have an assorted tooling of Helm charts, Docker files, container images, a new Slurm REST client library that's using the Slurm REST API. And then third is what's called the Slurm bridge. So the first two pieces that I mentioned are currently released. Here's a QR code that you can get more information on this and actually get access to the code in GitHub. Those two are released. The Slurm bridge is what's coming in the coming months. The Slurm bridge is basically a method to bring Slurm and Kubernetes together, where Slurm will be the one that is scheduling your Kubernetes workload and your Slurm workload. So now the Kubernetes workload is able to take advantage of Slurm's advanced scheduling capabilities and be scheduled alongside your Slurm workload. And again, keep your environments into a single place so you don't have to silo out your Kubernetes environment and your HPC environment, have them in a single location, and then Slurm is able to schedule that Kubernetes workload. Ultimately, to the point to be able to even have Slurm and Kubernetes workload on the same nodes at the same time. That's kind of what we're working towards. So more information will be continued to be revealed about Slinky as time goes. Highly recommend to kind of pay attention to KubeCon in April, as we'll be providing more information on that as we get closer and closer to the release of the Slurm bridge. It's important to note that Slinky is not a direct part of Slurm. It's not part of the Slurm code base. It's its own open source project. Slinky is not included in a SchedMD support contract for Slurm. It's its own complete team within SchedMD, own complete project. So coming forward with Slurm, in the next release is 25.05. Again, we're on a 6-month release cycle, so you'll see a new major version with Slurm every November and every May. With regards to these, every month-ish, we then do point releases with bug fixes and whatnot. But in 25.05, so coming out here in a few months, just a couple of points I wanted to highlight regarding this next release, is we have an increased network traffic encryption across all aspects of the Slurm daemon. So we currently have had encryption between Slurm DBD, the database side, and the Slurm controller. And now we're going to also have encryption that you can optionally enable between the Slurm daemons and the Slurm controller. That's the compute nodes that's communicating with kind of the Slurm head node. And so that can be provided full network traffic encryption. Also, because of our partners within the EDA and financial space, where they are pushing the limits of how millions and millions and millions of jobs on a daily basis, we're going to have a continued enhanced high throughput scalability to be able to push hundreds and hundreds and hundreds of jobs per second and keep up with that rate. I mentioned earlier the software license requests. We have full integration with kind of dynamic software licenses where Slurm can be made to know what is actually available if you're sharing those licenses. We also are now enabling the ability to have an OR operator. This comes from a lot of our EDA sites where they are needing to request multiple different types of licenses and get either this one or that one based on which one can be obtained at that time, so you can get a faster rate of start. One concept in Slurm is the ability for reservations where you can hold off a set of resources in the future. This will allow us to create these reservations via the Slurm REST API. And more information about the reservations that you are requesting are captured in the accounting data. These last two bullets are actually two bullets that we've been working very closely with the Google team on to provide a greater method for understanding topology when you're doing auto scaling within a cloud. Because when we are working on the cloud side, we are adding compute nodes when they're needed and then taking away those compute nodes when they're not needed. We want to make sure that those compute nodes are put within a specific network topology so that you can get the best internode communication. So we're working with Google to provide a topology plugin to work with the methods of adding compute nodes and finding out what that topology should be when those nodes are dynamically being added and taken away. Secondly, we're working with them to develop the ability to have multiple different network topologies in play at the same time. This comes a lot as we work with NVIDIA to support block topology. We want to be able to support that topology along with this GCP specific topology and this dynamic network topology to give you the most optimal runtime for your jobs across the many nodes that you're using. And so that's just kind of highlighting a little bit of that partnership that we're working with GCP on to make sure that we can support the needs that they have and that our customers that are using Slurm on GCP can do so in the most optimal way. So Slurm, SchedMD, and Google Cloud. How do we work together? Well, first of all, Slurm in the cloud really acts as a bridge between your on-prem and your cloud. And this happens in a couple of ways. Firstly, there are a lot of Slurm users out there in the industry, and a lot of Slurm understanding and use cases that have been going on. So sites are using Slurm on-prem, and so then now they need to start using the cloud. They want to get access to an extension of their resources. They want to get access to kind of more higher end, newer GPUs and special resources. They don't have to go and learn a new schedule. You don't have to go and learn a new way to submit jobs. You don't have to go and learn a new set of commands to figure out how you're going to submit your workload and all of that and manage your workload. It's just Slurm. From an administrative and end user perspective, if you've been using Slurm on-prem, it's the same as if you were using it in the cloud. There's really no difference for you. So it's the same type of experience. And so that makes it very easy to migrate from what you're doing on-prem to GCP. Also, to Slurm, whether it's a hybrid system where you're on-prem and you're bursting resources to the cloud, or you're all in GCP and auto-scaling resources, to Slurm, it doesn't really matter. It doesn't see those resources in any different way. It's just a Slurm cluster that has these nodes that are adding and being taken away. So Slurm really makes that transition to cloud for you very easy. And so we've been working with Google Cloud for 8+ years now on a partnership to to make sure that Slurm is running as optimally as possible in GCP. We jointly developed a number of cloud scripts that enable Slurm on GCP. This started with creating Terraform scripts to create the initial infrastructure of what your Slurm controller is going to be, what your Slurm nodes images are going to be, so on and so forth. Also, we created the pieces within Slurm that allow for that auto scaling. When you're doing Slurm in a cloud environment, you submit jobs, and then Slurm sees that it doesn't have nodes that can support those jobs right now that are currently available. So it'll go and provision more nodes. And so we have worked with them to optimally create those provisioning scripts that Slurm will call when it needs to add nodes and when it needs to destroy nodes. This has all then evolved into what is called the Cluster Toolkit, and Carlos will dive into the Cluster Toolkit in a lot more depth here in a couple of minutes. But as part of the Cluster Toolkit, Slurm is very well integrated, and we work very closely with the Toolkit team to make sure that Slurm continues to stay integrated. And there are a number of Toolkit blueprints that are predetermined and pre-created for you, and examples to really spin up a Slurm cluster in just a couple of minutes. And so within this type of use case, we're able to do auto scaling fully in the cloud, where you have a Slurm controller, maybe a login node or two, and you're scaled down to 0 from a node perspective. You submit workload, and then nodes are added when needed. When those jobs are no longer running and you don't need those resources anymore, those nodes are destroyed, and you're back down to a low amount of nodes. Also, as part of this project with the GCP team and Toolkit, supports doing a burst to cloud or a hybrid type environment where you can have your on-prem environment. And we see this as a lot of kind of that first step that a lot of sites take, because they already have their on-prem environment. Now they need to get access to special resources or extension of resources through just a handful of configurations. And using the toolkit, you're able to set up Slurm on-prem to then burst to GCP and get access to those resources. With this partnership, we want to help customers get set up in Slurm and GCP in as fast as possible, and try to kick down any of those barriers and those hurdles that you sometimes run into when you're trying to take that leap to cloud and with Slurm. So we've worked very closely with the Google team, and we have this program as part of the partnership. That's a 3-month proof of concept program that we're able to, during this three-month program, provide you technical onboarding and consulting services. So those services I talked about at the very beginning, those consulting services, we would work with you to help you migrate your workloads to GCP and learn how to set Slurm up optimally in GCP, how to set Slurm up in a hybrid environment and take your on-prem environment and start pushing those workloads to GCP. We provide a roughly 1-day jumpstart training to kind of get you a more understanding of how Slurm works, especially for those sites that haven't been using Slurm on-prem. And during this whole 3-month period, you get access to our full support. So not only do you get kind of a proof of concept of Slurm on GCP, you actually get a proof of concept of our support services that we provide you, and the help that we'll provide you in learning and getting more capable with Slurm. During this time, you will get access to an engineer that's assigned to you that will work with you to make sure that those goals that you have within that 3 months you're able to hit those. So if you have more interest in this, and highly recommend reaching out to hpc-sales@google.com, and we can work with you to enable this 3-month POC with you. Just to close out here, we want to highlight a couple of successful customer engagements that we've had with regards to that POC program. We worked with Broad Institute, where they came to us and needed excess capacity from on-prem. So they're working with GCP on this. They had on-prem legacy systems, an older scheduler, so they weren't really as familiar with Slurm. And so as part of this 3-month POC, we trained them on how to use Slurm. We moved their workloads over to GCP. Through that partnership, also developed a solution to enable them to do multiple clusters within the cluster toolkit and have multiple Slurm clusters that communicate with each other inside of GCP. Ability to preserve Slurm state across the rebuilds of the cluster environment. And they also, in the end, we're actually looking at bursting from GCP to their on-prem environment, and so kind of reversing the hybrid idea. And so within that 3-month period, they became very successful with Slurm and understanding how to use it, and then were able to accomplish all the goals that they had, and get Slurm into a kind of a production environment there for them. Another success that we had with the EJIE, it's the Basque Government Informatics Society. They migrated their workloads to Slurm. We're running them all in GCP. They like Broad, needed excess capacity. They already knew Slurm, and so for them it was an easy onboarding to run Slurm inside of GCP. But the whole idea of cloud was somewhat new to them. And then they wanted to offload research projects to cloud and really get access to more powerful GPUs. And so as part of this 3-month engagement, we provided them best practices and optimizations and how to use Slurm and Cluster Toolkit. We helped them with a script to use Slurm's Lua burst buffer plugin to help move data from the on-prem to the cluster when they're submitting their workload. They needed to use Aptamer images as well, and so we worked with them to accomplish those goals. So just a couple of successes that we've had that you can take advantage of this program, and start kicking those tires and learn how to use Slurm on GCP. At this point, I'm going to go ahead and turn it over to Carlos, and Carlos is going to dive into provide us a better understanding of how the cluster toolkit works, and then that integration with Slurm.
Thank you, Nick. Right. So first, I'll give you a quick introduction of the cluster toolkit, and then I'll speak a little bit about Slurm GCP, what it is, and a few of the recent or most important optimizations we've done that are specific to GCP on top of Slurm. So the cluster toolkit is a tool. It's composed of 3 pieces, right? Blueprints, modules, and infrastructure. It allows it's meant to quickly deploy and easily deploy clusters in Google Cloud that follow the best practices. We work really hard to have the intelligent defaults depending on what you're doing, and provide both general purpose, workload specific, and partner focused blueprints as well that show different use cases, right? The toolkit itself has various modules for storage, several modules for different schedulers, several other general modules like Pack support, Packer, and etc. Right? And why this is a priority for us is that the reality is creating a full HPC environment. It's a fairly complex thing, right? You actually have to touch on a vast range of services, right? A normal customer ends up playing with many different aspects of the infrastructure. For instance, in the case of UC Riverside, you see how many different things I have to touch on in terms of user environment configuration, scheduler, several networking configs, etc. So it all gets automated by having those blueprints that deploy the Slurm cluster and the entire full environment, right? The blueprint is responsible for creating the network, the file systems, the compute, sometimes installing and creating the images, installing the environment in the clusters, some part of the software stack, and etc. In fact, the blueprints are capable of creating a Google Cloud project, creating service accounts, activating APIs, etc. Right? So it's really powerful, allows you to have those best practices embedded in those blueprints. And it's a single file, which is also very interesting. So, and the journey, right, to use the toolkit is really you get one of those pre-configured blueprints, you tune it to your needs, right? Originally, you probably start off a simple blueprint, understand how that, what changes you may want to do, and then you call gcluster deploy which is the deployment of the environment, and it will deploy on the Google Cloud. Now, for you to have an idea of how the level of simplification and abstraction that is involved in here, the blueprint is a YAML file, right? The YAML may have, a default YAML may have 62 lines of code. Whereas if you were to call gcluster create to expand that YAML into a Terraform deployment folder, which is one of the levels that we provide, right? You would get about 3,500 lines of code. And if you actually call deploy, by the time you do Terraform in it and you really expand all the modules, Terraform scripts, etc., you're off with 40,000 lines of code, right? It's a tremendous level of abstraction to represent your environment in that YAML. So as I mentioned, the blueprint is really a higher level abstraction of the cluster. The modules are building blocks. They're abstracted, loosely defined interfaces. So we have interfaces for storage, for network that allow you to compose. You can change the type of storage in your cluster if you want cluster or versus if you want parallel store or file store, right? It's oftentimes a single line change. By changing the module you're referring to and using it across the other modules, if that single line change, you're effectively changing how the drivers get installed in all the VMs, how the volumes are mounted in all the VMs. All of that is automatic. We, of course, curate over 50 modules that implement the best practices for each one of those functionalities. But you also can pack to your own arbitrary Terraform code or Packer code. So a lot of our customers built their own modules and maintain them privately. It can be a GitHub, a Git repo, it can be a folder. So what gcluster does is that it behaves as a dependency injection factory, right? It's basically injecting the dependency between the modules and composing the higher level Terraform in a Terraform folder that is generated transparently, but you can see you have full access and control of the generated Terraform that later will be used to deploy your clusters. And a lot of our customers appreciate this transparency because they can learn from this Terraform, they can understand what's going on, and they can integrate that sometimes in their CI/CD pipelines that already exist, especially industrial customers, right? But also, and this is hard to, it's easy to underestimate, it does more than just Terraform, right? Because it does handle image creations. There are modules that are of type Packer, so it will be able to create images for your VMs. It will be able to handle software installation and initialization after the machines are created. Yeah, so that does all this. Sorry, I just saw a question flying by. What is the difference between HPC Toolkit and Cluster Toolkit? HPC Toolkit was renamed and is now called Cluster Toolkit. They're the same thing. Okay. Right. So, like I said, you have the blueprint. You call gcluster. It's the binary that does the dependency injection. It will compose the modules that are referred in the blueprint and create this deployment folder. The green box here. That is a mix of Terraform, Packer, shell scripts, Ansible. We heavily rely on Ansible, Terraform, and Packer. We try to pick a stack of technologies that were well adopted out there and easy to be, this is all open source, by the way, right? So we wanted something that could be industry standard, that people would understand and could leverage. And then, of course, you don't have to look into this folder. If you call gcluster deploy on the blueprint, it will create the folder transparently and then automatically deploy your infrastructure. But still, we feel it's quite powerful to have the deployment steps be fully open sourced and transparent to you. And we maintain a catalog of blueprints. You have here in this link, the catalog of the blueprints that we have over 40 blueprints. We have blueprints that are tailored for specific use cases, a lot of AI ML workloads, quantum simulation, general purpose HPC environments, healthcare and life science. Some of those blueprints go all the way to install the applications with SPAC, download the inputs for the application, and you have everything ready. You can just submit the simulation of your first simulation by the time it's deployed. And some of those blueprints are more general. in that you will create a cluster that contains the libraries and the runtime that you need to run a certain use case, but we don't actually give you the application to run. It's a generic cluster. And as an example, we recently released a blueprint for Nemo on A3 Ultra, right? What it does is it deploys a cluster with Slurm here, or controller or logging node. It creates a specific image for this controller. It allows you to deploy a partition of A3 Ultra nodes. It creates 2 networks for the host communication and 8 networks for the RDMA communication in between the compute nodes, in between the GPUs. It deploys file store as a storage system that is mounted for /home. It creates a object store bucket, GCS bucket, where you can use for data distribution, reference data, training data, etc. We have documented how to do parallel store, which is basically Deus. And automatically installs the NVIDIA drivers, the MoFed, the Mellanox drivers, CUDA, enroute, Pixies is configured. And you have the whole thing is ready by the time you do gcluster deploy. Now, I'll talk about topology in a minute, which is very interesting in this case. But first, we talked about Slurm GCP and the toolkit, right? And I wanted to mention Slurm GCP specifically, right? So Slurm GCP is a layer, right, on top of Slurm that is tailored towards GCP, right? Nick just mentioned it before, all the work we have done together with SchedMD, right? And it makes a lot easier for people to administrate, to manage Slurm on Google Cloud, right? It's transparent to the users. The users actually interface directly with Slurm once it's deployed, but then it provides extensions to Slurm in terms of providing more functionality and connecting to lower level Google APIs. Sorry, I missed one. Yeah, so Slurm GCP contains all the customizations. It's a core component of Cluster Toolkit. The recommended way for you to use Slurm GCP is through the toolkit. So when you deploy, you interface with the Cluster Toolkit. There you will see various modules that exist, like a controller module, a logging node module, a node set, a partition, and you configure those in the blueprint. And by the time you hit gcluster deploy, it will leverage Slurm GCP and create infrastructure, right? And that is the reason we did that is that the toolkit has many other modules, like a storage, for instance, and networking. And then it's very easy for you to just say, use parallel store or use file store. And that means Slurm will be automatically configured to mount those storage solutions, to leverage the RDMA networks and the normal networks, and has already the right configurations for the right MTU size, the right firewall rules that are expected. Everything is configured for you. And I mentioned some of the things we did recently for that are specific, right, to our platform. So Nick mentioned the auto-scaling, for instance, right? Slurm GCP knows how to dynamically create and delete the compute nodes. So when you create a partition with dynamic nodes, what will happen is as you submit a job, for instance, right, what can happen, not necessarily, but what can happen is as you submit a job, and let's say your job uses 1,000 nodes, it will make one API call to something we call the bulk API. And that API will automatically create the 1,000 nodes. You're not going to pay for any of those nodes until the 1,000 nodes are available and created for you. And this is very powerful because there are cases where you would otherwise be waiting. You have 900 nodes and you're waiting for the 1,000 to be complete. This won't happen here, right? It will automatically create all the nodes required for your job. And depending on how configured, the default is that those nodes will be created per job and as compact as possible. Right, they'll be part of a placement group that will make them as compactly placed as possible for that specific job. The other thing we've done recently, very recently, is that the topology tree plugin is used by default. And the topology.conf, Slurm's topology.conf file is automatically updated with topology information periodically. So if you create and delete a VM, or if the VM live migrates, whenever topology is available to the VM, we'll get the latest topology, and that will be updated in topology.conf, which is extremely powerful because it provides a sizable performance improvement, right, to your workloads, especially large distributed highly coupled workloads. The other thing we have also done somewhat recently was this integration to our maintenance API. So depending on the machine family in Google, you have different notifications for maintenance events, and up to 90 days. So you might get a notification that this node is scheduled for maintenance, and you have a deadline for that maintenance on February 18 at 11 p.m. What Slurm will do is Slurm will automatically create a Slurm reservation around the period of that maintenance, and meaning that any job that has a duration that could be scheduled during that time, could be running during that maintenance, won't be scheduled in that node. Either the job has a shorter duration and is guaranteed to finish before the maintenance occurs, or the user, well, the administrator can opt to trigger the maintenance earlier. There are many things you can do about it. But the fact of the matter is that you won't have inadvertently your job interrupted in the middle of your simulation or the middle of your training because of a maintenance event, right? And this is very powerful. Increases your ability to train and make progress dramatically. Finally, we have integrated health checks in the Slurm epilogues. You can choose to do prologues as well. But basically, if a job finishes, it will do verify basic GPU health. And if the GPU is detected as unhealthy, it will turn that GPU down, mark the node as down, and potentially resubmit the job if it failed, right? It will resubmit, but now only on healthy nodes. And this also improves your quality of life dramatically because it maximizes the time your simulations are productive. Sorry. And with that, I would like to invite to try it. We have tutorials, various tutorials in the GitHub repo and also in our Google Cloud documentation page. If you follow this link here in the dyno, you have this guide me tutorial that will guide you step by step on how to create your first cluster and run it in Google Cloud. So good luck. Jay?
Great. Thank you, Carlos. Nick, if you could come back online now, we'll go to Q&A. So the first question submitted, Nick, I think you largely answered it in your slides, but I'm going to ask it anyway because I want to make sure that we get the big picture set for everybody here. The question is, why this workload management can't be done by Kubernetes, though it has access to HPC hardware? Why Slurm? I think the question is asking, why do you need Slurm on top of Kubernetes? What advantage does it give you?
Yeah, we get this question a lot. Or so why can't I just do the HPC with Kubernetes? Why do I even need Slurm? Well, they were both designed for different purposes. And so instead of trying to make Kubernetes do what Slurm does and Slurm do what Kubernetes does best, let's let them do what they both do best, and then Slinky is the thing that's going to bring them together. So with Slurm, by bringing them together with Slinky, you get the advanced scheduling capabilities that Slurm has had for 15, 18 years, whatever, and you get those advanced policies. So as part of that bridge, your Kubernetes workloads are going to get access to all those policies that can come in well. Also, with Slurm can provide more optimization for extremely large jobs. Like we find that about 1,000 nodes, Kubernetes really struggles, but that's Slurm's sweet spot. And so you have that. And so with like the AI workloads, we find your inference workload works really great on Kubernetes. Workloads that are in your long running processes and those type of things. That's what works great on Kubernetes. More of your batch, your your training workloads. Those work great on Slurm, and so you can bring those together with Slinky.
Sounds good. One of the most popular questions submitted: do you have training content and workshops on how to best run Slurm with top AI ML training frameworks? PyTorch, JAX, Hugging Face, Lightning, etc.
So at SchedMD, we don't have anything published. We can for sure help you as part of our consultation and training. I don't know, Carlos, with the quick labs or anything like that, if you have anything specific to that.
We have in this page here, you will find documentation on how to install the toolkit, use the toolkit to deploy Slurm for various different AI/ML workloads, right? NeMo, Llama 2, etc. In the toolkit GitHub repo that you can find through this page as well, there are many other blueprints that also are customized for this. And I believe we do have quick labs. I would appreciate if, Wyatt, can you implement on that?
We do have quick labs. It's part of our HPC workshops. So if you reach out to hpc-sales@google.com, we can put you in access to those.
Great. All right. Next question that I'll select here. Is there a way plan for Kubernetes and Slurm to understand each other's resource pools and be able to exchange nodes?
Yeah, so that's basically Slinky, where with the bridge, all of Kubernetes workload will actually go through Slurm. Slurm will then be telling the Kubernetes scheduler API where to place the workload. So Slurm will understand what Kubernetes workload is out there. It won't actually be running the workload, but it is creating, like you could say, like a placeholder job within Slurm, so that it knows what's running from the Kubernetes perspective. So when it's scheduling Slurm workload, it can schedule around that, and then it makes the decision of where the workload should run, the Kubernetes workload, and then passes that on to the scheduler API on the Kubernetes side, and then it places it. So that's the whole idea. Is that on a compute node, you would have a kubelet and a Slurm daemon both running on that compute node, sharing those resources. You can almost think of it like a Venn diagram. You have your Kubernetes resources, your Slurm resources, and then of those, you can determine how much do you want to share amongst both of those.
Carlos, was there anything you wanted to add to that? All right.
No.
The next question, I'm going to probably rephrase it slightly here. No, I'll go ahead and ask it as it is. Based on SchedMD's experience, which cloud provider has the best Slurm cluster for HPC workloads, or is it Google Cloud only? But I will add to that, based on Google's experience, which scheduler does Google have the deepest integration with? So Nick, you want to take the first part of that?
Yeah, so what I'll say about Slurm and clouds is Slurm is very agnostic with regards to clouds. So Slurm, because again, to Slurm, it's the same resources, whether on-prem or cloud. But yes, we do love working with Google. They've been a great partner. We find it very easy to spin up a resources with Cluster Toolkit and have a Slurm cluster in there. And then add on to that the relationship we have with Google in making sure that, again, Slurm is going to be optimized within their environment, and working with them for so long, you will definitely get a lot of mileage out of Slurm running on GCP.
Carlos, do you want to speak to from the Google side on the relationship with SchedMD and Slurm?
Yes, I think it's, I will confirm everything Nick just said, that we have been working together for a very long time, right? We have deep integrations. You saw in our previous slides that the toolkit has support for various schedulers. But I would say that without a doubt, the deeper integration we have is with Slurm and GKE, of course. Yeah.
All right. I have another question here. Is Slurm positioned better for hybrid workloads only? I don't think the word only was probably meant there, but can you speak to the positioning of Slurm for hybrid workloads on-prem and in particular GCP?
Yeah, so that's where Slurm fits really well, is hybrid or all in cloud or all on-prem. It's kind of no difference for Slurm. It's just finding a compute resource. The only difference with hybrid than all in GCP or all in on-prem is from a networking perspective. You've got to make sure your Slurm controller can communicate with the compute nodes that are in the cloud. That's the kind of only difference to do it. Slurm, as long as that can happen, it's going to schedule workload to those compute nodes, auto scale those nodes as needed, and scale them down when no longer needed. So yeah, whether it's all in cloud, it's very easy to just spin up an environment with Toolkit. With hybrid, there are a handful of more steps you have to take, so it's a little more involved. Is where our POC comes in really handy with hybrid, especially because you have your production environment already running, so you got to configure that to work with these new nodes that you're spinning up in the cloud. But yeah, either scenario works really great with Slurm.
And Nick, I'm going to ask you.
Add,
oh, go ahead,
sorry.
Carlos.
Apologies. I would like to add, right? We have customers doing hybrid bursting to cloud. We have customers running Slurm only entirely in Google Cloud, right? And we have an increasing number of customers who also have Slurm on Google and bursting to on-premises.
Yeah.
So those three use cases have been fairly popular for us.
So I'm going to ask my own follow-up to that question. Is there documentation or training for customers to do this, or does this require a special consultation and POC?
There is some documentation in the Cluster Toolkit GitHub project. There's some documentation there. It is one of those things with the hybrid that does require a little bit more finesse, just because again you have your production environment and you don't want to do anything of misconfiguration there. So it is one we highly recommend working with us on that.
All right. Question from Lucy Hutchins. Once the cluster has been deployed, what is the best way to increase the compute node set size?
Yeah, great question. So,
sorry.
No, go ahead, Carlos.
Oh, sorry. I was going to say, with the cluster toolkit, if you deploy it with a blueprint, you can just edit the number of nodes there in the blueprint and call deploy again with the -w flag, and it will reconfigure your cluster to the new number of size. You can also add and remove partitions.
Yeah, I'd add that with Cluster Toolkit, we like to see that as being the source of truth for your configuration, and so you just change that and redeploy, and now your environment has the ability to grow larger.
All right, I think we have time for one more question. This question is, how to distribute workloads on multiple GPUs using Slurm? Are there any Slurm directives we can use?
Yeah, so Slurm treats GPUs as a first-class citizen. So just like you submit a job requesting multiple CPUs, you can submit a job requesting multiple GPUs, which type of GPUs, so you can be very specific of the exact type that you want. And there's a number of integrations with Slurm on how you would do those submissions. To the point of even saying I want dash GPU equals blah. And getting that different type of specific GPU that you require. The CUDA visible devices variable is set that then tells you which GPUs on each of the nodes that have been assigned to your job are there for it. So then your job can know which specific GPU that you need. And then using our C group integration, we're able to constrain those work resources or those workloads to the specific resources that you have assigned to your job.
Great. Well, thank you very much, Nick and Carlos. Really appreciate the information you shared with our community here today.